This is the review worksheet for pre-calculus for chapter 4. One, paper organized here. We have f of x equals the absolute value of x minus 1. And we are supposed to give the domain and range and zeros of the following function. So I look at that graphically. So if I plug in -1, I get 0. And if I plug in 0, I get -1. If I plug in 1, I get 0. If I plug in 2, I get 1. If I plug in -2, I get 1. Absolute value is a v. It goes something like this. So this moves the parent function, this part of it moves the parent function down 1. Okay, the parent function would be the one that opens from, the origin. So domain, all real numbers. There's no restrictions on the domain. Range, obviously I did not get anything down here below -1. So we say y is greater than or equal to -1. And then the zeros of the function, I can tell those graphically. I don't need to try to solve this. They are positive and -1. So the zeros are 1, 0 and -1, 0. Number 2, we have f of x equals the square root of 9 minus x squared. So again, I look at that graphically. If I plug in 0, I get 1, 2, 3. If I plug in 3, I get 0. And if I plug in -3, I get 0. Anything in between there, I'm going to get decimals or fractions. If I plug in 4, I actually get 9 minus 16, which is the square root of -7. And we're not going to graph that. That's an imaginary number. Same thing going this way. If I plug in -4, I'm going to get 9 minus 16, which is, again, not part of this world. So this is the equation for the top half of a circle that has a radius of 3 and its center at the origin. Domain is between -3 and 3. And you can write it like that. You can write it in bracket notation. In bracket notation, it would be written like this, okay? The range is from obviously 0 to 3. So again, we can write 0 less than or equal to y, less than or equal to 3. In bracket notation, it would look like that. And again, I can look at the graph and I can tell you that the zeros of the function are 3, 0 and -3, 0. Okay. To get all that, I didn't even have to do, the only algebra I had to do was when I plugged in a number to try to figure out where the point was on that graph. Okay, for part 2, it says, let f of x equal 8 minus 2x minus x squared. Okay, and so we want to sketch the graph and then find the domain and range and zeros of the function once again. Well, this is a parabola, and that negative right there tells me this parabola opens down. And to find the vertex of this parabola, I use the opposite of b over 2a. So I get -1 for the x coordinate of the vertex the y-coordinate of the vertex would be 8 minus 2 times -1 minus -1 squared. So that's going to be 8 plus 2 is 10, minus 1 is 9. So my vertex is at 1, 9. And this thing opens down. So I'm actually going to do this like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So as I said, my vertex is at 1, 9. So that is way up yonder. And then what I'm going to do is I'm going to plug in 1. And if I plug in 1, I'm sorry, 0. If I plug in 0, I get 8. And if I use my axis of symmetry, I get the point, the mirrored point over here. And then if I plug in 3, okay, 8 minus 6 would be 2, minus 9 would be -7. Gosh, did I do that right? 3. So 8 minus 6 would be 2, and 3 squared is 9. So yeah, -7. So I'm not gonna graph that. Obviously the zeros on this are not going to work out well. It doesn't look like 0 equals 8 minus 2x minus x squared. So I'm going to make that x squared plus 2x minus 8 equals 0. And does that factor to x plus 4, x minus 2? I think it does. So that gives me x plus 4 equals 0, x equals -4, x minus 2 equals 0, x equals 2. We have a problem. What am I doing wrong? Daggone it. I hate it when I get started on something and then make a mistake, especially when it's on a review. And then I'm not seeing what I did wrong. Minus 2x squared. Well, I see my mistake. I don't know if you guys do. I do. My vertex should be over here at -1. And then when I plug in -1, I'm going to get 8 minus 2 is 6. Well, I did plug in -1. But up here I wrote 1. What did I do that for? That was silly. So 8 minus 2, 6. Still, what I did was I had it at +1 instead of -1. So my other point over here should be at 2. And then my zeros are at -4 and +2. And we look like this. Okay. So I don't know. I plugged in -1, but up here I wrote +1, so I graphed +1, 9. Obviously that's wrong. So my domain is all real numbers. My range is y is less than or equal to 9, and the zeros are -4, 0, and 2, 0. Okay. And that is everything they wanted. So then Part 2, I give you the equation that f of x equals 2 minus x over x squared plus 9, and g of x equals negative 2x. And for number 5, I want you to find f of g of 2, which means I plug 2 into g and I get negative 4. Now I want you to find f of negative 4. And that's going to be 2 minus negative 4 over 16 plus 9. Looks to me like that is 2 plus 4 is 6. 16 plus 9 is 25. That fraction doesn't reduce. And that was number 5. Number 6 wants me to find f of g of x. So that means they wanted me to plug in g into f for x. So I'm going to have 2 minus negative 2x, because that's g, over negative 2x squared plus 9. And it looks like I'm going to have in the numerator 2 plus 2x, and in the denominator I'm going to have 4x squared plus 9. I don't know if you've noticed, but I don't have to worry about any restrictions on this fraction, because that's x squared plus 9, and there's nothing I can plug in to make this a negative, so it would cancel this out and go to 0. So we are safe in that respect. Number 7 wants me to find g of f of 2. Okay, well, f of 2 is 2 minus 2 in the numerator over 4 plus 9 in the denominator, which is 0. So that means I need to find g of 0, and g of 0 is 0. Okay. And then number 8, we want to find g of f of x. So in other words, we're going to plug f into g for x, which means we're going to have negative 2 times the quantity, 2 minus x over x squared plus 9. Well, that fraction there, looking that way, isn't going to simplify. To simplify this, I just need to distribute this 2 to the numerator. Okay, so simplified, this will be negative 4 plus 2x over x squared plus 9. Okay. Okay. Moving along then. My computer was acting funny there for a second. I'm laughing hysterical on the inside. Number 9. I give you the equation x cubed plus xy equals 6. And we want to know if it has symmetry with respect to any of those things that are listed on the review. And so to check, the first one is the x-axis. And to check for symmetry in the x-axis, xy gets mapped into x minus y. So I go to my equation and I change anything that's y to minus y. And then I ask myself, do I have the exact same equation? And the answer here is no. So, on the little blank there on the worksheet, I would write no. Or on the test, I would write no. And then we check the y-axis. And to check the y-axis, xy gets mapped into minus x, y. So wherever there's an x, I change it to minus x. And I ask myself, is that exactly the same? And it is not. This would be negative x cubed minus xy equals 6. That's not the same equation. And next on my list is the line y equals x, and to check for symmetry in the line y equals x, xy gets mapped into yx. So I interchange x and y, which will give me y cubed plus yx equals 6. Is that the same equation? It is not, because y cubed is not the same as x cubed. And then lastly, I check for symmetry in the origin. And to check for symmetry in the origin, xy gets mapped into minus x minus y. And so we change anything that's x to a minus x, and anything that's y to a minus y. And this part of the equation does stay the same. You know, that becomes plus xy, but because that negative is being cubed, that becomes a negative x cubed. So it has symmetry with respect to none of these. Okay, and that's how we check for that. Okay, we have a closed box with a square base made of material that's $16 per square meter for the top, $16 per square meter, and $8 per square meter for the sides. Okay, and what we have, as it says, we have a square box or a square base. I got way out of proportion. We have a square base that does have a lid. Okay, because it's a square base, I'm going to let this be x, and I'm going to let this be x, and I'm going to let this be h, which is the height. Okay. In order to write the cost equation, I need the area equation. And so the area in terms of x and h, the area of the bottom is x squared and the area of the top is x squared. So that's 2x squared. And then there are 4 sides, and the area of each side is x times h. So I need to add in here 4xh. And then to get the cost equation in terms of x and h, you know, this represents the area, how many square meters the top and the bottom are. So that costs $16. And then this represents the area of the sides, and those cost $8 to make. Then we simplify that, we get 32x squared plus 32xh. Okay. And so there's your cost equation. For number 10, it says, you know, express the cost of the material for the box as a function of x and h. Well, that's what we just figured out. 32x squared plus 32xh. And then if the volume of the box is 8 cubic meters, express the cost of the box as a function of x alone. So in other words, get the h out of this top equation here. Get the h out of that cost equation. And to do that, I use the fact that the volume is 8, and the volume of this box is x times h, or x squared h. And if I want to get the h out of here, because I want to write this as a function of x alone, then h equals 8 over x squared. So now I take that and I plug it into my cost equation for h. So that's going to give me the cost in terms of x equals 32x squared plus 32x times h, which is 8 over x squared. And I get 32x squared plus 32 times 8 is 256 over x, because this x will cancel with one of these. And in the book, they may have gotten a common denominator and put that together. That's not my goal. So the answer to number 11 is c of x equals 32x squared plus 256 over x. That's what I'd be looking for. Okay. Part 6 says let h of x equal negative 2x plus 3. And they want us to graph h and h minus 1, find a rule, and state the domain and range. Okay, easy enough. Again, when I go to graph these, I like to make a table, even though it's a line, and I could easily graph it using slope-intercept form, which is what it's in. Okay, but I like to make a table because it makes it easier for me. I don't know about you, but it makes it easier for me to graph the inverse if I have a table. Okay, so I am going to plug in, I don't know, negative 2, and that gives me positive 4 plus 3 is 7, and I wrote 3. Gosh, so 7 is what I should have written. And then I'm going to plug in negative 1, and I get 2 plus 3 is 5. I'm going to plug in 0 and get 3. I'm going to plug in 1 and get 1. I'm going to plug in 2 and get negative 1. Okay, so I put in a lot of points, but the reason, because I'm not going to graph negative 2, 7. That one is a little bit too ambitious for me. Okay, so I'm going to start at negative 1, 5, which is here. And then I'm going to graph 0, 3. And then I'm going to graph 1, 1. And I'm going to graph 2, negative 1. And I get this line. Okay. And that is h of x. And then to graph the inverse, I'm going to flip those around. So I'm going to have 5, negative 1, 3, 0, 1, 1 will be my spin point. I love that point. And negative 1, 2. So 5, negative 1, 3, 0, 2, 3, 1, 1, right there, same point, and negative 1, 2. That gives me that line. That is h minus 1 of x. And if you wanted to, you could put, there's y equals x. That's what we just flipped over. If you wanted to put that in there lightly. Okay. So then for number 12, it says find a rule for h of x, h minus 1 of x, and that means write the equation for the inverse. And the way I do that is I say y equals negative 2x plus 3, and then I interchange x and y because that's what a inverse is defined as. Okay, and then I solve that for y. So x minus 3 equals negative 2y, negative 1/2 x plus 3/2 is y. So h minus 1 of x is negative 1/2 x plus 3/2. Okay. And then it wants me to state the domain and range of the inverse. Well, it's not real interesting. It's a line, and the domain of the original line is all real numbers, and the domain of the original, or the range of the original line is also all real numbers. The domain of the inverse is all real numbers, and the range of the inverse is all real numbers. So like I said, nothing real earth-shattering there. It's a little more interesting when we're finding the inverse of a parabola. Kept it easy. It's a line, so I'm hopeful for some really good grades on this test. Everybody's grades are going to go up, and we have no worries. Okay. So there we are.